Hey guys, this is the second tutorial in the series. This is going to cover an introduction to Python inside of Rhino. We can start by just opening up Rhino, and in this case, I'm actually going to show this introduction instead of in the Python script editor inside of Rhino. We're going to just go ahead and jump straight into Grasshopper. That way we're familiarizing ourselves with the Grasshopper interface and Python at the same time. And when we get more into Grasshopper, we'll already be somewhat familiar with the interface. The way to enter Grasshopper inside of Rhino is just to click into the command prompt and type Grasshopper. Newer versions of Rhino come with Grasshopper pre-installed, so you don't need to worry about an additional download or installation. Once the Grasshopper window opens, you can just double click and type something and then hit enter, and that's gonna open up a new window. You can also go to File, New Document. And anytime you have multiple Grasshopper documents up, something helpful to know is that you can click on the name in the upper right of the window, and you notice that we now have two documents. Both are unnamed documents open. We only are visualizing one in this canvas, but both are open. So if we wanted to close out of one, we can just hit this X here. We can say no because there's nothing in that document. You can right click and drag to pan, and you can use the scroll wheel to zoom in and out. And if we had components in our Grasshopper canvas, then we could hit this view entire document or focus upper left. In this case, it's not actually going to do anything. We don't have particular components and we're not off of the origin. I'll introduce Grasshopper a little bit later, but Grasshopper is a visual coding interface. It's going to involve dragging components or working with components visually on this canvas space. Right now, we're just going to focus on one component in particular, and we're going to access this component by double left clicking on the canvas and typing Python. You should see this Python script, which again didn't used to come with Grasshopper. It should be pre-installed in newer versions of Grasshopper. So if you just left click on that Python script, it's gonna pop up this little object here. This is a Python scripting component. So this is gonna be our primary interface for Python inside of Grasshopper. If we scroll into it, we can see a few things with this component. We have an X, a Y, and then we have an out and an A. We may get into these a little bit more once we kind of discuss the general Grasshopper interface and look at that more in detail. But as I describe some of the aspects of Python, I may also be referring to how they may relate to the Grasshopper interface. To access this component so that we can start writing a Python script, we're going to just double left click on this name here in the middle. That opens up this Python script editor, and this is going to be our primary Python interface inside of Grasshopper. What's nice about this is instead of relying on pre-made components like any of these in the tabs up at the top here that we see in the Grasshopper window, this Python script editor allows us to use the programming language Python to write custom script to customize the kind of geometric workflows or algorithmic workflows that we may want specifically for one project. So I'm going to just go ahead and start by deleting this. Although this is helpful information stored here at the top, all it's saying is provides a scripting component. The inputs to this component are seen on the left here, so X and Y. If you're familiar with Grasshopper, you know that the inputs into a component are on the left and the outputs are going to be shown on the right of the component. And then in the middle is just the name of the component. So it tells us here that there is an X input variable, a Y input variable, and then the output is the A output variable. In this case, we're going to just go back through that from the start, so we don't actually need that right now. Similar to that, this import is just a way of importing libraries, which we'll discuss later on. We don't need any libraries right now as we're just covering the basics of the Python programming language at the moment. So there are a few data types that are really important to note once we get into Python. In this introduction, I'm going to cover a few things. The first being variables, the second being conditionals, the third being loops, and the fourth being functions. So we'll get into each one of these as we go through this tutorial. The first data structure we're going to look at is variables, which are containers for different data types inside of Python. These come in a few different types. The first is strings, and then we have integers, floats, booleans, and lists. So these are our primary variables we're going to look at the moment. We may discuss particularities of each one of these a little bit later, but this is going to just cover a general introduction. So a string is going to be a variable that stores text information. So the first thing we can do is make a variable text, and we're going to set this equal to the data we want to store in the string variable text. So we can specify that this is a string by opening quotations, and we can type anything following this quotation. So hello world, and then end the quotation. In the Python script editor inside of Grasshopper, if we hit test right now, nothing is going to happen. We're not outputting any of these variables. If you hover over the A, you see that that's null because right now we only have one variable, which is text, and it is storing the string hello space world, but we aren't outputting that or printing that, so we won't visualize that in any way. If we want to visualize it inside of the Grasshopper Python script editor, we can just hit enter, type print, and then type that variable name text. If we hit test again, we can now see it's printing hello world, so it no longer has the quotations around it, but it is registering this as a string variable. If we want to display this hello world message outside of this Python script editor, we can right click on this A and change this A to the variable that we have set in the script editor. So that would be text. Now, if we hover over text, we can see that it says script output text, one locally defined value, hello world. If we want to visualize that a bit larger or easier to see in Grasshopper, we can double click in the canvas, type panel, click on that panel option, and then we're going to just click on this semicircle white node as the output from this Python scripting component and plug it into our panel. So now it's going to display that variable text, and it displays hello world as a string on our panel. So as we go through each of these variable types, we're going to just output both to the panel and also visualize this by printing inside of our Python script editor. The next variable type is an integer. So an integer is going to be any whole number. So we can make a variable num. If we don't want it to override the text, it's important that it's not that same variable name. So any name will do, as long as that name does not overlap with any library that you are using or some existing function. So right now num is going to be okay. We can set this to any whole number. So 1, 2, 3, let's just say 3, and then we can print num, hit test, and we can see that it's now printing our text, hello world, and then underneath that, it's also printing our integer, num, which it has a value of 3. If we wanted to output this num variable, not just into our Python script editor, but to this panel out here, all we would need to do is zoom in a little bit and we can see these plus icons. We just are going to hit plus. This gives us an option for another output. We can right click on that one, select the A at the top and type the name of our integer variable, which is num. And now if we plug that node in, it's going to say null because we need to rerun this. So hit test again, and now it registers 3. If we want to visualize both of those, we can just left click and then hit Alt on the panel. That's going to duplicate it. So we now have 2 panels inside of Grasshopper. We can just drag the text output to one, the num output to the other. The next variable inside of the Python script is a float. So a float is just going to be a number with a decimal value. So this allows us to not just use whole numbers, but use any real number. So if we do num f equals and then we can say 3.24, and then print num f. We can see that printing below the integer value 3. If we just right click on that num and type _f and then hit test again, we're now outputting the float variable instead of the integer one. Below that is booleans. So booleans are going to be a 0 or 1 or true or false value. We'll see how this is used later on in conditionals. So what we want to do here is just type any variable name, and we can set this to true. It's important that the true or false, the first letter is capitalized. So we now see it print out that the bool is true. If we change this to false, it's going to print false below that float value. Before we get into lists, I'm going to quickly describe some operations we can do with these variables. So the first variable, a string variable, we can either print the entire string, but the string is made up of individual characters, which would be HELLO space WORLD. These are going to be itemized from 0 to whatever the length of the string is. So if we wanted to just print the first letter, H, then we can say print text. That's going to print the entire hello world. And we're going to just open brackets. These are square brackets, not the curly brackets. And we're going to use the item index, which I mentioned is 0 to whatever the length of the string is. So 0, close the brackets, and hit test. So it's now printing here the entire string, and then print text item 0, it's now printing H. We can go through the entire string, so 1, test is E, and so on. With integers, we can actually perform mathematical operations on them. So we could make a variable called result. We can set that variable result equal to num times num. This is going to take the variable num and multiply it using the asterisk symbol times itself. So if we type print and then result, so now we see that the num value is printing there 3, and then we're getting the result, which is 3 times 3, which is 9. We can do this with any mathematical operation. So num plus num, that's 3 plus 3 equals 6. Num minus num should give us 0. Num divided by num should give us 1. And we can see here that it actually adjusted the output value and is giving us a float value as a result now. So an integer divided by an integer, it's outputting a float value. These mathematical operations can be used for floats as well. So if we just move this result variable down here and we say num f divided by num and then test, we can now see that we have hello world, the integer, the float value, and then we have 1.08, which is the result of 3.24 divided by 3. The next data type is lists, which works similarly to the variable types above, except for a list is going to store multiple of these variables. So it's going to be similar to a string variable, which is able to contain a list of characters. Lists are going to be able to contain multiple integers, multiple floats. We can start this by typing list equals, and then we're going to do something somewhat similar to what we did with calling an item out of the string variable, which is open brackets. And if we just close it right now, hit enter, type print list, and then test, we can see that it's just printing those brackets. This means that the list is empty, but it is signaling that it is a list that's been created. It just has no items in it. We can do a list of strings by opening the brackets, typing hello, and then separating each item in the list with a comma, and then world. And now if we hit test again, we see that there are 2 items in the list. One is hello, which is a string, and one is world, which is also a string. If we only want to print hello, again, works similarly to extracting a character, an individual item from the string. We can open brackets, type 0, and then close the brackets and hit test. So now it is only printing hello, which is the first item, the first string in this list. If we want to print world, we just change this to a 1 and hit test. A useful tool for later coding exercises. If you don't know maybe how long that list is going to be, but you definitely want the last item in the list, you can set this value to -1, and this is going to give you the last item in the list. So list -1 is going to give you the last item. Another option for this is list, and then you can type len, open parentheses, so that's going to call the function length, and then we can give it list and then hit test. So this is now going to give us an error, index out of range 2. That's because the length of the list is 2, 1, 2, but when we're calling indices, we start at 0. So what we need to do if we're going to use the length of the list is we need to add a -1. So length of list -1, that will give us the last item, which is world. If we don't just want to print world, but we actually want to print the last item of the last item. So this is going to read as a nested list, which is a list of characters, which is a string, inside of a list of strings. So right now we're grabbing the last item in the list. So now we want to grab the last character in that string. So we can just open up another bracket, and again, we can type -1 and close that. This should give us a printout of just the last character, which is D. So the last character in the last item of the list. If we wanted to print the first item, or actually let's say print the first item, but print the last character of the first item, we can change this to 0 and then leave the second index at -1, which will give us that last character. And it's now giving us O. If we wanted to add to this list, we're going to use append. So if we just hit enter, type the list name, and then a period, it gives us a few options to work with. We can remove items from the list, reverse the list, or sort the list. Right now, we're just going to use the append function to add an item to the list. I'm going to add the string hello again, and then close that parentheses. And I'm going to take out these indexes so we print the full list and hit test. So now it's printing hello and then world and then hello again. This list now has 3 items because we've appended to this list. The next thing we're going to talk about is conditionals. Conditionals allow you to construct rules for which parts of a script are run under which conditions. So this will make a little bit more sense when we get into it. So conditionals are going to work with true or false statements. So this could be directly a Boolean value, true or false, or it could also be a statement of equality or inequality. So does this equal this? If yes, then run this piece of code. So the syntax for this is going to look like if something is true, and then a colon, and then when you hit enter, the Python script editor is automatically going to indent for you. And then anything in this indented space is only going to run if something, the variable, is true. So we can test this by typing print, and then we can say true. And then right now, if we hit test, it's saying name something is not defined. So something is not a variable at the moment. So what we need to do is type something equals, and then we can set this as a Boolean value and say T true. So right now, something equals true. If something equals true, which it does, print true. A conditional only operates for things inside of this tabbed space. So anything outside of the tabbed space, so let's say here, will print regardless of whether that condition is true or not. So if we hit test, the conditional is true, so something is true. It's running print true. You see that print out. It's also running print after. If we change this value of something to false and then hit test, we can see it's no longer printing true, but it's still printing after because it's outside of that tabbed conditional space. If we still wanted to do something else, even though this variable is false, one way of doing this is to hit enter inside and type else in line with the if statement. So in this case, there's no tab, else colon enter. And now we have a second tab space, which we can type print false. So right now something equals false. If we wanted to have multiple conditions and not just if one thing is true or false, we can add elif conditional statement, so else if, which will read first whether the initial statement is true or false, and then we'll add an additional condition to run that conditional. So if we hit enter, type elif, we now can't just put a colon and then inside of that tab space print false or something like that. Instead, we need another condition to satisfy that else if portion of that conditional. So we can say something else equals true and then colon enter, and we have that third tab space in which we can print other or whatever message you want. And now we can label something else equals true. And when we hit test, so this is actually an important thing to note. In conditionals, so statements of conditional equality or inequality, we're not declaring. So in variables, we declare with a single equal sign. We're declaring something else does equal true. But when we're reading it conditionally, we actually need in Python 2 equal signs to test its equality. We're not declaring its equality, we want to test its equality, which requires 2 equal signs. So now if we hit test, we can see that that conditional is satisfied, so it is printing the other. It is no longer printing false because once one of these conditionals is met, it does not go to the next one, so it will just print do whatever is inside of here. So we can do this without just printing, so we've established a kind of basis of rules for these. Let's say instead of just printing messages, we actually want to make a variable result, and we want to make 2 variables num1, num2, and we're going to make these equal to 1, or let's do 7 and 5. And then maybe we'll also do a num3 and then make that 4. So if something is true, instead of just printing a message, we can have it actually perform a mathematical operation. So anything can be placed inside of here, but I just want to show you one example where we can do different mathematical operations and then print result here. We don't need to actually declare it equal to anything. So if it's true, we're going to say result equals num1 plus num2. If something else equals true, we're going to say result equals and we can say num1 divided by num2. And else, so that would be if both of those are false, then result is going to equal num1 plus num2. And similar to mathematics, if we keep that in parentheses, it'll perform that addition first, and then we can divide by num3. First, I'm going to change something to true, hit test, and we can see it's printing out result equal to num1 plus num2, which is 12. If we change that value to false and then hit test, it's satisfying the second conditional statement. So something equals false, but something else is true. But if we change something else to false, we will see this value down here, 1.4, change. So now it's 3.0, which is 12 divided by number 3, which is 4. So we're getting 3.0. Okay, the next data structure we're going to get into is loops. So loops are going to allow you to cycle through certain items within a particular range. So if you had a list, it would allow you to iterate over each item in a list and operate on each one for each item. So meaning if you had 4 items in a list, it would allow you to run something 4 times. This will be, I think, easier tested instead of explained maybe. So let's take our list up here. So we have that list, which we've extended. So I'm gonna just use that. The syntax for loops, the base syntax is going to be for, and then we can just have a variable item, so for item, and then in whatever your data set or set of data is. So in this case, we're going to use the list, and then this is going to be followed by a colon and enter, and similar to conditionals, it automatically tabs us in. So for each item in this list, which means for item 1, which is 4, 2, item 0, which is 4, 1, which is 2, and so on, it is going to perform some operation which we specify in this tabbed portion. So in this case, I just want to print that item. So I'm going to just use for item in list, print item, and we should see this loop iterating through each item in the list and printing them out in our printout below. So if we hit test, we can see item 1 prints, so that's 4, and then 2, 8, 9, 14, and 17. Now, it's printing the actual item in this list. If we just wanted to not print this item, but instead just print a certain index value, so let's say for the kind of length of this list, we wanted to print an index, we can use things like length list. So when we print length list, we see that the length of that list is 6. If we wanted to iterate for that length of the list, then we're going to use the syntax for I in range and then the length of the list. So if we just type range here, open parentheses, close parentheses at the end, it's going to print out here what the range of that length of the list is. So above this, maybe I'll just print length list still, hit test. So we will see the list printed out there, 4, 2, 8, 9. Maybe I can just do that here so we see them all stacked up together. So 4, 2, 8, 9, 14, 17, that is the actual list. The length is 6, but the range of the length of that list is 0, 1, 2, 3, 4, 5, which is 6. So that's the length of 6, 0, 1, 2, 3, 4, 5. So if we just cut that range length of list, then paste it in there instead of list. And now if we just hit test to print that item, we're going to get 0, 1, 2, 3, 4, 5. If we wanted to now iterate through the list in the same way we just did for item in list, but we want to use something like for I in range list, printing off those I index values, 0, 1, 2, 3, 4, 5. But instead of the index value, we wanted to use the index value as the index for the list. It's going to give us the actual item in that list. So item 0 is going to be 4 and so on. So it's now printing 4, 2, 8, 9, 14, and 17, which are the actual items in that list because we're calling the index values using the loop through the index values for the range of this list. Often using for loops, you actually want both of these things. You may not want to always write the kind of syntax out of list and then open brackets, I, close brackets. You may want to have the actual item data, but you may also want to have which index value you are in the list. So the way to write this is going to be for I, comma, item in, and then we need to use enumerate open parentheses list. Now if we print I, print item, and then I'm going to just delete that top one, we should be able to see, it's a bit hard since we're printing out so much, comma, and then I'm going to just add index value as a string so that we know that that's the index value, and then I'm going to add item as a string there so that we know which one's the index value, which one's the item. So we see taking out I, index value 0, which is for the first item, index value 1, that item is 2, index value 2, that item is 8, and so on. One other type of loop is a while loop. So a for loop is going to loop through or iterate through each item in a particular list or for a particular range. But a while loop is going to run until that condition is false. So if I just said bool equals false, said while bool, and then we said print while loop is running. If we hit test right now, we're not going to see that print out while loop is running. That's because it's saying while bool is true, or while bool. This syntax is the same as saying while bool is true. It's not. We've declared it false, so it's never going to run that while loop. Instead, if we said num equals 0, and then we'll say while num is less than 10, and don't run it yet because we've declared num equals 0, which is always less than 10, so it would run forever. So this is a dangerous statement right now that we have here, because your computer is going to run this statement forever and you'll need to force quit. So what we need to do is put in some operation that makes num eventually not less than 10. So one way to do this is going to be to say while num is less than 10, and then let's say num equals num minus 1. So every time it runs inside of this while loop, oh, sorry, that's important. We're actually adding up in this case, so we're not reducing. So num equals num plus 1. So every time we run a step in this while loop, it's going to add 1 to the variable num, and eventually that is going to be greater than 10 or not less than 10, and it will stop this while loop. Better syntax for this num equals num plus 1 is to just say num plus equals space 1. So this is going to be the same thing functionally, and it will add 1 each step in this while loop. So if we do this, we'll see that this condition is going to be true for 10 steps from 0 to 9. So if we see this, we see it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is still less than 10, but if you go one more step further, then num equals 10, which is not less than 10. If we say less than equals 10, then we will get an additional step, and it will actually run for 11 steps, including 10. So now we have 10 while loop is running. This is because we properly put num plus equals as the last line in this while loop. We don't want to force the kind of misconception that if we added it up here, that it was somehow reading the num plus 1 instead of the actual num that it evaluated for this conditional statement. The last thing we're going to talk about in this introduction to Python is going to be functions. So functions allow you to wrap certain operations inside of a module, so a function module. This is going to allow us to then call that module anytime we want that set of operations to run. This is going to be one of the more heavily used things in algorithmic design. It is also going to later relate to something we'll introduce in a different tutorial, which is going to be classes. These are going to seem very similar with slight differences between them. So in a function, the syntax for functions is, or the structure for functions is going to be that we first declare or define the actual function itself. We place things inside of that module. So whatever operations we want to do go inside of that module. And then later, Python would not read that if we did not call the actual function. So to define the function, we write lowercase def, and we can see that goes blue. So we're defining a function. We can name this function addition function, and then we can open parentheses, close parentheses, colon, and then hit enter. And similar to loops and conditionals, when we hit enter, we can see that it tabs in, and we have a kind of tab in space with now a option to minimize this, which means we can minimize this module. When building a function is actually going to take an input. We've seen a few of these. Enumerate here is a call to the function enumerate, which is just happening in the background of Python, this Python script inside of Rhino. And we're feeding an input of this list. In this case, we're gonna just pass in a number. I'm gonna just say integer, so num equals 1, or let's say 0, and then we're going to pass in this num, and maybe inside of the function we'll call the num1 so we don't get it confused with this num here. Every time we run this function, we are going to want num1 to add 1 and then return. So this is going to pass this value num1 outside of our function whenever we call it. So all we've done is fed in num1, which is not the same variable as num, and we've added 1 to num1 and then returned it. So if we hit test, it is not going to do anything at the moment because we have not called our function. If we want to call it, we can do that below the function. So we defined it and then we call it. If we hit test right now, it should give us this error saying addition function takes exactly 1 argument and 0 are given at line 67 in the script. So I've called the function, but I haven't given it an input. So it's giving me this error message because we have an input defined in our function. So we're going to pass it num, and we're going to say result equals that function. Now if we print result, we should see it feed in num, which is 0. That's going to become num1 when it gets passed into the function. And then it is going to add 1 to that and return num1. So we should see result equal to 1. Now this only runs once. If we want to run this multiple times, let's say like this, so result equals addition function num, and then let's actually pass in this time result, and then result equals addition function result. We're gonna see the first result would be 1, the second result would be 2, so it should print 2, and it does. We could do this however many times we want, but if we were smart about this, we would actually notice that we can use an earlier data structure, loops, to do this for us. So what we can say is for I in range 10, then we can say num equals addition function num. So we're both setting the output to num and keeping the input as num. And then if we here print num instead of result, and maybe actually to prove this, I'll just tab that in first so we can see all of the outputs. But we see that num equals 1 and then 2, 3, 4, 5, 6, 7, 8, 9, 10. But if we tab this print out, then all we'll see is that last value, so num equals 10. That's because it's run this addition function 10 times to go from 0 to 10. If we wanted to do this with 2 number values, then we could actually say addition function and then input num1, num2, say num1 plus equals 1, num2 plus equals 2, and then we are going to need to separate these with a comma and return num1, comma, num2, which will give us both of those as an output. So right now it's giving us that same error as before, which is that we've only input one variable into the function, but we've defined it as taking two. So we now actually need to give it a second input, which we can say is num0. And if we run this, it is going to run, but one issue is that we're feeding in num0, which becomes num2, we're adding 2 and then returning it. But it's actually going to return two variables, and then we're setting those two variables equal to the 1. So this is going to cause an issue. So when we hit test, we see unsupported operand for plus equals tuple, which is going to be these two as a tuple, which is similar to a list, and it cannot add a tuple to an integer, which is 1 there. We can fix this by, in our output where we call the function, also having this type of syntax. So num, comma, num0 equals addition function num and then num0. And then we're going to print both of those. And just to show it again, I'm going to tab that in. So we can see they start at 1 and then 2, 2 and 4, 3 and 6, 4 and 8, and so on. And then if I just tab that out, which you can backspace, or you can select that line and hit Shift Tab, and that untabs that line. And then if we hit test, we just see that num is equal to 10 at the end, and num0 is equal to 20. So that is going to be all for this introduction to Python script inside of Grasshopper. The next tutorial is going to cover a few algorithmic design structures related to these introductory Python methods.